All right, welcome back to the architecture track. Um, we're going to have Ryan Baxter up next talking about cloud native applications, next generation cloud native applications with Spring Cloud. So take it away, Ryan.
Thanks, Craig. Appreciate the introduction. Welcome, everyone. Welcome to my home office here in the lovely state of New Hampshire. I hope everyone is doing well and staying safe. I hope someday we can all be in person together, but this is a great opportunity to learn a lot virtually and take advantage of all the benefits of doing things virtually, like the great chats and the many different rooms that you can interact with us at and via Slack. So I encourage everyone to do that as well. So I know Spencer and Olga just gave a great talk, and I'm going to follow it up with a little bit more Spring Cloud talk. And this time we're going to be talking a little bit about Spring Cloud and Kubernetes. And if you were just attending either Spencer or Olga's talk, or you're attending Dave Sire had another talk right before me as well. And he also is talking about Kubernetes. So either one of those talks would be great follow-ups to those sessions. So get ready, and I'll start sharing my screen here. So just make sure I share the right screen. All right. See that. All right, so let's get started. So first I have the usual legal statement that we have to show to everyone. So I'll give you a minute to read that. And if you really want to read it further, I'll be happy to send it to you afterwards as well. Just a little bit about me before we get started. So like I said, my name is Ryan Baxter. I'm a husband and a father of two small kids that actually just started school today. So they should not be running into my office and interrupting our session today, which is a good thing. So they're all back to school. So we should have this time to ourselves. I'm a longtime Java developer. I've been writing Java since I was in college and university, and spent a while at IBM before joining Pivotal and now VMware, and joining the Spring team. I've been working on the Spring team for a while now, for around 5 or 6 years. I can't really remember. I have to double check on when I started, but it's been a while. And the whole time I've been on the Spring Cloud team, doing a lot of work with, like I said, with Spencer and Olga, and the rest of the Spring Cloud team, and obviously closely working with the Spring team as a whole as well. Super grateful and lucky to be part of such an amazing team and organization, and be surrounded by very smart people, and constantly learning in awe of what they do every day. So encourage everyone to take advantage of joining the sessions given by everyone on the Spring team, because you're sure to be wowed by what they all present. When I'm not doing my fatherly duties or working on Spring Cloud, I spend my time exercising and training for obstacle course racing. So you can usually find me downstairs in the basement in my home gym that I built, or running on the trails here in New Hampshire. So a little bit about me. So to get started, kind of talking about what it means to build Spring Cloud applications that are run on top of Kubernetes. We should really start by talking about where Spring Cloud was and where it's come from, and where it might be going. And so we'll take a little bit of a step back and talk about that first. So years back, this term started to appear called microservices, and later cloud native applications. And it was a new way of building and running applications, right? Traditionally, we had monolith applications, huge applications, lots of code. It was a single app. It encompasses everything, right? The whole application lived inside this monolith, and we found that it was hard to maintain and didn't really work very well when you started to move these types of applications over to the cloud. So the term and idea of building an application that's cloud native came around, right? And we started to take these monoliths and break them apart into things we called microservices, which are sort of small, very focused pieces, applications that did very specific things. And they're much more maintainable. They're easier to deploy and manage and run in the cloud. But as we did this, we ran into a new set of problems, right? We needed to be able to talk to all of these applications, right? One application needed to make a request to several different other applications. So how did it, do that? And, the cloud was very dynamic. So, an application might be running at this IP address today, but tomorrow it would be running a completely different IP address. There might be multiple instances of that application running. Sometimes configuring those applications it was not possible to do things like pull configuration or write configuration to the file system. So we need to figure out a different way of doing configuration. When you had multiple instances of an application running, you had load balancing, and you had to think about load balancing across all those different instances. And then, of course, while the cloud is great, there's also room for failure, right? So we had to prepare for failure and be more resilient. So a lot of these concepts started to emerge as we started to break apart our applications and move them to microservices, and then eventually move them to the cloud. And Spring Cloud did a great job trying to solve a lot of these problems, right? We saw the need for things like service discovery with services like Netflix, Eureka, and Zookeeper, and Console, and we externalized configuration via the Spring Cloud config server, and we provided circuit breakers to prepare for failure with Spring Cloud circuit breaker, and before that Netflix's Hystrix library. We had load balancing with Netflix's Ribbon, and now Spring Cloud Load Balancer, right? So we solved a lot of these problems using other technologies, and we made it in typical Spring fashion very easy to use, consume, and integrate into your application. And there was much rejoicing. And then, so we had lots of cloud platforms start to emerge, right? We have, all the popular big name cloud platforms like AWS and Google Cloud and Microsoft Azure. And we had open source projects emerge like Cloud Foundry, and you could even run your own cloud in your own infrastructure, right? And we had Spring Boot evolve and Spring Cloud come along to then make it very easy to deploy these applications to these clouds, right? And as that started to happen, these platforms recognize that everyone building these cloud native applications, they all ran into these same problems, right? That they needed service discovery, they needed load balancing, they needed routing, they needed externalized configuration. In some cases, they needed circuit breakers and provide resiliency in some way, right? And they started to introduce all these different types of services into their platform. They integrated these things into the platform so that, because they're just common use cases across the board, that people started having, right? I can remember the days back in the only thing that AWS used to offer was EC2, right? And now you go to the AWS services menu and you see an endless list of services, and just trying to find the one that you're looking for seems like a monumental task. So, the platforms have done a great job of providing features and functionality that are part of the platform to make building cloud native applications much easier. So we think about your typical Spring Cloud application, it kind of looks a lot like this, right? And this is just very basic, right? But this is kind of the basic thing that we see a lot of applications, right? In this case, we have two boot apps, that are running. We have configuration externalized in a config server here. In this case, it's backed by a Git database or a Git repo. But this could be anything else that the config server supports, such as Vault or Subversion or the file system or whatever your choice is, right? In this case, I just put Git here. That seems to be the popular choice. We also, the config server can optionally take advantage of Spring Cloud Bus and use something like RabbitMQ to notify applications when configuration that they might be using has changed so that they can update their configuration in real time without having to restart the application, right? That's a feature that is key and very popular in of the config server. And then we also have a service discovery server, right? This could be Eureka, Zookeeper, Console, whatever your choice is down here. And the applications use Spring Cloud to register with that discovery server and also fetch data of the other services, where they're located, how many instances there are, et cetera, from the discovery server. And when you have this set up, we also have libraries for things like circuit breaking, load balancing, and tracing that we mentioned, that then the applications can then use to take advantage of this data, right? So the boot app will pull in its configuration data from the config server. It can use the discovery server to fetch data about, for example, boot app B and how many instances are and what the IP addresses or host names are. And then it can use like Spring Cloud Load Balancer to load balance requests across the multiple instances of boot app B, and maybe put a circuit breaker around that. So if that boot app B starts behaving badly, it can trip that circuit breaker and at least not bring down the entire application. And then we have tracing to trace requests back and forth between all the other different applications, right? So this is just something that I think a lot of people who use Spring Cloud today are quite familiar with. So as I mentioned, as these platforms have started to recognize various different use cases of building cloud native applications, they've taken some of the pain points that every app developer experiences, and they've pushed it down into the platform so that the platform provides support for these things, as opposed to having the application developer or the app having to worry about it. Right, so Kubernetes is no different in that case, right? Kubernetes is an amazing platform. It's one that I think a lot of people are excited about, including myself. And I think it provides a lot of advantages. But it also recognized that we have a lot of different use cases, and we're running all different types of apps on top of Kubernetes. And it tried to, or does, solve a lot of these common cloud native concerns at the platform level, right? So if we were to take the same application that I was just showing in the previous slide that was using Spring Cloud and said, I want to re-implement this application or write this application to run on Kubernetes, it might look something like this instead, right? Here I have, instead of Spring Boot app A and B, I have pod A and B, but you can imagine these being the same thing. Pod is a resource inside of Kubernetes, which is running the application inside a container. So just in case anyone's unfamiliar with that. But for configuration in Kubernetes, you have two different resources called config maps, and one I don't have pictured here called secrets. So config maps are just general configuration data. It could be a properties file, it could be just key value pairs, it could be a YAML file, etc. A secret is for more sensitive data, usernames and passwords, right? Things that you don't necessarily want people to be, viewing in the open. And in either one, it doesn't matter. They both work in the same manner, but how the application then uses that data is by configuring the pod so that data gets mounted as a volume in the file system inside the container, or as environment variables inside the container. And then it's up to the application to then either read that file or look for those environment variables, which is quite easy to do with Spring Boot today. If you have a YAML file and a config map, you can mount it as a volume and point to that file in your Spring Boot configuration, and it will read that file and contribute those properties as a property source in the application. And same with environment variables, right? And then for service discovery and load balancing and routing and those types of things, they're all a side effect of creating what's called a service in Kubernetes. So just a little background: a service is a way of exposing a pod or a set of pods to the outside world, so that it can be, you can make a request to it, for example. So the fact that you create a service for a pod then acts as a form of registering that service. That's equivalent to registering that service in a service discovery server, if that's what you're familiar with. And we'll have another example of this in the next slide to explain a little bit more about this. But basically what that does is it configures a set of DNS entries as well as environment variables, which contain the IP address, the protocol and the port number, that then can be used by any other pod. So, right, if I have service A here, the IP address, the protocol, and the port number for service A gets there are environment variables created inside this pod, or registered, or I guess created inside this pod, that pod B can then look for and use to figure out, what's the IP address of service A? What port is it running up, exposing? What's the protocol it's using? In addition, Kubernetes also configures DNS entries so that pod B can say, I'm going to make I'm going to make an HTTP request to HTTP service A, and it knows how to route that request over to service A. So it does both those environment variables as well as creates DNS entries inside the pod, so that these things actually work. In addition, the act of registering a service also acts as a load balancer in Kubernetes. So when pod B calls service A, via its HTTP request, this service acts as a load balancer and will load balance requests across multiple instances. So we have multiple instances of pod B here. Service A makes a request to pod A makes a request to service B. It will then load balance the request across all the different instances of pod B running. Right? As far as circuit breaker and tracing, those things would work the same as they work today. There's no difference, when using those types of things in front of when running on Kubernetes. You still would wrap the HTTP request, for example, in a circuit breaker, and still add your normal tracing configuration, etc. Now, there are some differences and maybe potential downsides in this when doing things in this way. From a configuration point of view, if this config map changes, you can go in there and change the config map values dynamically. The file in the volume will actually change as well with it, but there's nothing telling the application that configuration changed. So it's up to the configuration to actually figure out whether it changed or not. There's obviously ways to do that. But one may also make the argument that you could do what's called like a rolling update here, where if you change the configuration for pod A or pod B, you might have multiple instances of that application running, and then you just one by one restart each instance. So there's always an instance running to serve traffic, but you restart them one by one to restart them with the new configuration data, essentially, which is a perfectly valid way to do it. But I know that as a longtime Spring Cloud developer, that people also love the automatic refresh functionality that the config server provides. In addition, if your application is using the config server today, you're going to have to make some changes here so that when you deploy the application onto Kubernetes, that you no longer look for a config server and instead look for a file in a given volume or some environment variables, etc. So there's some additional work you would have to do here. The other thing here is if this was using a discovery client implementation, like say pod A was a Spring Cloud Gateway, and it was using load balancer and a discovery client to route requests. That would be a bit of an issue, right? Because there would be no discovery client implementation then running in Kubernetes, because you don't have one here, right? It's all taken care of by the platform. The other thing is this load balancer that's happening here at the platform level. You really don't have much control over what algorithms are happening here. So, however the platform operator has configured the load balancer algorithms in Kubernetes is what you get. You don't have any control over it. Whereas if you had client-side load balancing, you'd be able to pick an algorithm, maybe depending on the service or the application, so you have a little bit more control over as a developer, right? So those are some issues that you might run into when we're comparing the two, a Spring Cloud approach to maybe just a Kubernetes quote unquote native approach. So just to review here, in case you're looking for equivalence here, we have to what Spring Cloud provides, we have a config server. The Spring Cloud config server would be equivalent to using things like config max and secrets. So you have load balancing, which is done at the Kubernetes service level. Again, the act of registering a service in Kubernetes basically exposes it to other pods running in Kubernetes. So that's kind of your discovery server. As far as the discovery client end of the piece, so figuring out where a service is located or how to make a request to a service, you have host name resolution. So you could say HTTP my service name, right? Whatever the service name is that you created for that service. Or you can look at the environment variables inside the container and figure out what the IP address and port and protocol is. And they kind of, this is an example. If you had a Redis service, for example, running, this is what this might look like as far as environment variables inside the container. So a few years ago, I guess it's been a few years now, we had a community project startup called Spring Cloud Kubernetes. And so they realized that there is this kind of gap between what Kubernetes provides as a platform and what Spring Cloud has traditionally offered as far as APIs and interfaces, et cetera, right? And the community started a project called Spring Cloud Kubernetes, which the Spring Cloud team eventually adopted and brought under the Spring Cloud organization in GitHub, and has since been maintaining as part of the work that we do on the Spring Cloud team. And so they provided implementations for a lot of these things, like configuration and load balancing and service discovery out of the box with Spring Cloud Kubernetes. And to our kind of naive detriment, I guess, on the Spring Cloud team, we weren't really that versed in Kubernetes at the time. We were like, oh, this works really well. But eventually we found that one of the major barriers that the initial implementation had was that it leveraged the Kubernetes API server a fair amount. So all the pods that were using Spring Cloud Kubernetes basically had to have access to the Kubernetes API server to do a lot of these things, to read configuration, to basically use to have a load balancer, to basically fetch information about other services using a discovery client. And in some organizations that's okay, but in some organizations it's not, really the right approach. They don't want the individual applications being able to talk to the Kubernetes API server, and by default, when you deploy a pod or an application to Kubernetes, that you're not allowed to. You have to give it special permissions. So there are some easy solutions to this problem and maybe some not so easy solutions to this, right? So the first thing we did was tackle kind of the configuration problem, because it was somewhat easy, right? Because you could already take a config map or a secret and mount it as a volume or surface it as environment variables inside the pod. And that was fine. And the boot app could read that volume or those environment variables use that configuration in the application. And it also, you could change these values and it would actually update the data inside the pod, which is great. But you didn't have that refresh capability, right? And the way that Spring Cloud Kubernetes out of the box would do this refresh functionality was it would create what's called a watch, which is a Kubernetes concept. Again, needed access to the Kubernetes API server to do this, to watch the config map to see if it would change, and then refresh the application context if it did. So to break that tie to the Kubernetes API server to do this, we introduced an application in Spring Cloud Kubernetes that you can deploy kind of like an infrastructure level application or a Kubernetes controller, you might want to call it. It doesn't really matter. But you can deploy this config watcher from Spring Cloud Kubernetes to your Kubernetes environment. And it's the thing that talks to the Kubernetes API server and watches the config maps, and then use a Spring Cloud bus or it can actually do this over HTTP as well, but whatever method you choose. It then notifies the application that its configuration has changed and refreshes it. So the only thing, instead of each pod having to watch, use the Kubernetes API server in order to watch it for configuration changes, it's just the config watcher that talks to the Kubernetes API server. And then we use, Spring Cloud Bus and HTTP to notify the pod, so that breaks that dependency to the Kubernetes API server for that piece of functionality. But still, inside of Spring Cloud Kubernetes today, the discovery client implementation, as well as the load balancer implementation, they all still require you to talk to the Kubernetes API server in order to do that, right? So if you need a discovery client implementation, you're still going to have to talk to the Kubernetes API server to get the list of services and all that stuff. So it's not in the ideal state yet. But what I want to talk to you about today is where we're going to be heading. And this is much more about where we're going to be going. And this is what this looks like. So the first thing you're going to notice here is that none of the pods are talking to the Kubernetes API server anymore. Hooray, right? We've made sure that that's still the case, right? We don't want to have that as a dependency for the applications. The other thing you're going to notice here is that we also have, in addition to this config watcher, we now have two new things, right? Well, not new things, right? We have a Spring Cloud config server. This is a config server that you're all love and familiar with. You've used forever from Spring Cloud. But it, in addition to the existing environment repositories that can talk to Git, Subversion, file system, SVN, Vault, whatever, we can also pull in data from config maps and secrets into the config server. So if your application is currently using a config server and has data from Git that it wants to pull in, but you also want to maybe provide some Kubernetes specific configuration and keep that in config maps and secrets, the config server will allow you to do that. And then we also have this new thing called a Spring Cloud Kubernetes Discovery Server. And this is, you can, for all just basic conceptual purposes, you can think of this kind of like Eureka. It's not Eureka, but it behaves a lot like Eureka in that it's just a set of REST endpoints that allow you to fetch service information from the various different services that are registered in Spring Cloud in Kubernetes, right? So the one difference is that in something like Eureka, the pod or the application would actually register with the discovery server, right? It would send a request and say, hey, I'm a service and here's where I'm discoverable at. With this implementation, that doesn't happen. Again, the act of creating a service here in Kubernetes is the same, is basically how you register the service, right? So the Kubernetes discovery server, it talks to the Kubernetes API much in the way that config watcher does to figure out the services, their endpoints, their IP addresses, their ports, etc. And that's how it gets the data that it then can feed back to the applications, right? Same with the config server, right? The way it's monitoring or the way it's getting data for the config maps to surface into or to serve alongside other environment repositories in the config server to the pods is by talking to the Kubernetes API server. So we're trying to keep this model where you have a couple of maybe Spring Cloud infrastructure-like components that you might deploy. They're the ones that need access to the Kubernetes API server. They're the ones that have special permissions. But outside of that, every other application that you're going to deploy here that might use Spring Cloud does not need that, right? But now this opens you up to, again, having a discovery client implementation that you can use. You can use client-side load balancing at that point. Again, circuit breakers and tracing still work the same way. You can choose to use these services. You can then mix and match components. Like if you don't want the config server, you just want config maps and you want to mount them as volumes and do all that stuff. You can do that. You can not include the Kubernetes discovery server and just leverage, the environment variables and DNS routing if you want, right? So then you can start to mix and match things. But this model here in these services then make it much easier to basically choose the approach that fits you, right? So when people ask me, should I use a config server or config map? How should I do service discovery? How should I refresh configuration, right? There is no right answer here. It really depends on what you're building, where you're coming from, and how you're trying to, your specific situation. Like I can't give you one answer. There is no one size fits all, right? So basically what I'm saying is you can choose to use the platform as is and not use any Spring Cloud components at all. That's a completely fine approach to building a cloud native application that runs on top of Kubernetes. I fully support it. I think it's great. I have no problem with you taking that approach, right? If you're building a greenfield application, something that is just going to run on Kubernetes, go for it. Like there's nothing stopping you from doing that. It might make your life even simpler, right? It might even be a better approach. But if you're taking applications that might be running somewhere else that are already using Spring Cloud and you're trying to move them to Kubernetes, instead of having to rewrite them and change them and recompile them and do all this crazy configuration to get them to work in both places or whatever, I feel like these new components in Spring Cloud Kubernetes could make that transition a lot simpler. Or if you're planning on keeping them running in both environments, maybe you have a Cloud Foundry deployment over here and you have a Kubernetes deployment over here, and you're going to deploy some applications Kubernetes, some applications in Cloud Foundry, or both in both environments. This makes moving them back and forth and running them in both places a lot easier. So it really all depends on what you're doing in your use cases, right? So what I want to do next is demonstrate this to you, to show everyone, right? So I'm a big fan of demos. I think that's much more impactful. So let's leave that up for later. Okay. So what I have here, I'll show everyone. I don't think we're going to need that window, but we will need this IDE window here. So I have a very basic application here. I'll try to make text bigger so everyone can see it as well. But I'm going to describe it as first. This is just a basic Spring Cloud application. We have a config server that's pointing to a Git repo. It's using Git as a backend. Inside that GitHub repo is really just one single file. You can see here, this is the repo it's pointing to. It's just an application YAML. It has some basic configuration, which is stuff around actuator and some other things, Eureka, that we'll explain a little bit later on, but that's what that's doing. Again, nothing fancy happening here. It's just has a @enable config server annotation on it. We also have a discovery server, and this is, again, very basic, just Eureka, nothing fancy going on. We have @enable Eureka server. That's the only thing that's going on here. Then we have a couple of different quote unquote microservices. So we have a fashion application, we have a hot deals application, we have a toys application. This is kind of just a very basic like shopping example. It just surfaces data about, maybe toys, some hot deals that might be happening, and some fashion items, right? And in front of those microservices, we have a gateway, which is just a Spring Cloud gateway. Again, this is nothing terribly unique or fancy about this application at all. It has a couple routes configured, which for each different microservice that you can reach. So you can see here, they also have a circuit breaker here wrapped around them that goes to a fallback method, which just returns an empty list. So nothing incredibly fancy again. There is a REST controller here, and I'll save you from trying to read all the code, but basically all it does is aggregate. It calls all three different microservices and aggregates all the data together into a single response. That's it. Nothing terribly exciting. So I'm going to start this up, and while all the applications, actually the discovery server is already running, config server is running, and so I just need to start the other ones. Yep. So we should start fairly quickly. I'm just going to wait for the microservices to start and register. Get that away. OJ. They're all started. Okay, and then I'll start the gateway. Okay. The one thing I'll mention that is a little bit fancy about the toys application is that it's using a library called Chaos Monkey, which is a really cool library for doing chaos engineering. And one of the things it does is introduce random latency into REST controllers so that you can randomly have it say take 5 seconds to send a response back. And that's a good way to test whether upstream applications can deal with the slow delay response from downstream applications. So that's why the gateway has everything wrapped in a circuit breaker. So when the toys bestseller has this random latency pop up, that it will fall back to the fallback, and the circuit breaker will be tripped, etc. As a demonstration of that. By default, it's disabled. So Chaos Monkey is not running when I start this application off the bat here. So I'm going to pull up my terminal window here. I'll close some of these other ones so I don't get distracted. And I will clear this here. So we'll just demonstrate how some of these work. So I just need to remember the ports of everything that's running. 8083 is the hot deals. /hot deals. Let's see. We get some. I'll make this window a bit bigger for everyone as well. There we go. And I'll make the size just a little bit bigger. Okay, so that's a problem. So we just get some JSON back from that endpoint, right? The fashion application running on 8082. So if we do HTTP : 8082 / I've made the window big so you can't see what I'm typing. Get it a bit smaller. Try this. All right, 8082 / fashion / seller. Here we get some fashion items that are bestsellers, and then we can do I believe the toys services on 8081. So 8081 is going to be there's still text being cut off somewhere. Try this. Set up / There we go. So there's toys. All right. Now with the gateway application, we can do, like I said, there's that we can route to each individual service. 8070 I think it is. But we can also hit this start page, which then aggregates all the data from all the services into a single response. So we can see that all here as well. All right. So I mentioned that the gateway here, the toy service has Chaos Monkey enabled, or has a library there. It's not enabled. So this might be easier to look at in the browser. So if we do HTTP /8081 /actuator Chaos Monkey, we see that it's currently disabled. We can enable it by using making a post request to actuator Chaos Monkey enable. And that will enable Chaos Monkey. So we can see here, it's now true. And we'll do this here just for the sake of it. You can see that we get some random latency here. The toys response was triggered. That took a little bit to come back. So we got the fallback, again, the fallback. And here, this next one, we got the remote service. So if I keep on refreshing the page, randomly we get, the random latency, and we get the circuit breaker triggering. And then sometimes we actually get the actual response to come back. So that's how the application works. Now, what I want to do is bring that application, including all of its Spring Cloud components, over to Kubernetes, right? So I have a cluster deployed to AWS, or set up in AWS here. It is completely empty. If you're, in case you're wondering, it should be completely empty. Yeah, there's nothing running. If you're wondering what this is I'm using, it's a cool little tool called Lens. I just found out about it the other day. I really like it. As far as the GUI is concerned, the other tool I really like, in case you're wondering, I'll just throw out some random advice, unsolicited. If you're more of a CLI guy, K9S is a really cool CLI tool, which I've been using in the past to see, what's going on inside your cluster, inside of Kubernetes. Anyways, random piece of advice, but we're going to stick with Lens for right now. It's empty. There's nothing going on. There's no config maps. There's no deployments. There's no pods. There's no services really running. There's some default config maps and secrets that are part of the cluster, but other than that, there's nothing here. So we're going to go ahead and deploy things, right? So I mentioned we have that discovery server, that config server in the config watcher, as far as like infrastructure type components that we want to run to support us running on Kubernetes. So I'm going to deploy those. I have all the deployments and all the lovely Kubernetes YAML that everyone loves from Kubernetes already written out, so we're not going to have to go through and do that. So I have these YAML files here. The one thing I will point out that's special in these that really you're really only concerned about is for the config server, I have its configuration set to include the Git profile, right? And it's pointing at that same GitHub repo that our local host config server is pointing at. So this looks exactly the same, right? So we're going to go ahead and deploy those, and then while that's getting started up, we'll talk about something else while we wait for it to happen. So I'm going to do kubectl apply -f, and we want all the stuff in the infra directory here. So that's going to go ahead and create all that stuff. We should see, various things happening here in our deployments and pods now spinning up, which is good. But while that's happening, I just want to go ahead and take a look at some of the configuration inside the applications that we're going to be running. Now, these are really this toys bestseller, the hot deals, the fashion application. They're really just kind of basic boot applications. There's nothing crazy going on. If we look at their application YAML here, like I said, they're really just a boot application with a REST controller. There's nothing really fancy in any of these. They all look pretty much exactly the same. The configuration, as you might imagine, is just using Spring config import, pointing at the config server in the local host in the local case here. I'll try to remember to make the text bigger. And on Kubernetes, we have it pointing at the Kubernetes config server, right? Where does this DNS name come from? I'm sorry, this host name come from? Again, this is the name of the service in Kubernetes. So you can make HTTP requests to that service, right? So if we look back here, the configuration server, and I'll make this a little bigger and find service. Here we see the name is this, right? And that matches what we have here. And the port number 8888, right? That also matches the port that we're exposing in the service, right? So that's basically what how that works. This Spring config activate on cloud platform Kubernetes, a nice little configuration enhancement that Boot has added. I believe it was in Boot 2.3, but it might just be in 2.4. I can't exactly remember what was added, but definitely in 2.4. but it basically allows you to activate this YAML document on a specific platform. So they have various different cloud platform options here. One of them being Kubernetes. So this Spring Cloud config import statement is only going to be activated when we're running on Kubernetes. And this configuration looks exactly the same across the hot deals and the Toys Bestseller application as well. So I'm not really going to bother showing you them. The gateway, it's only different in that it also uses Discovery Client. So in addition to the Discovery Server, I've written a Discovery Client starter in the Spring Cloud Kubernetes here. Again, this is something new that isn't in the open source yet that I've written for the, as a demonstration purpose here, and hopefully will be in open source fairly soon. It's in my GitHub repo, my fork, so you can check it out. But that's the only difference here for its as far as differing from the other apps in any way. Configuration wise, it looks like, this application configuration for the gateway looks exactly the same. So all these are up and running here. I'll just quickly demonstrate some things to you. If we go to the services for these, I have them, they should be exposed, and sometimes start off in a discovery server here. Sometimes these external IP addresses don't resolve as quickly as I'd like, but let's see if we gave it enough time. So this is the discovery server. It did, great. So this should look pretty much exactly like if you're familiar with the response you would get from Eureka. It should look pretty much the same, right? You see you have the config server, you have the config watcher, right? These are the only things that are running right now as far as services. But it has the host port, URI, all the same stuff that you're normally used to here. And then for the config server, let's try that out here. That is running the 8. Oh, I need to actually tell it /application/. Right now, you're only going to see data from the GitHub repo, right? But this is basically the config server. You can see that this is the data coming from the config server, the GitHub repo, and the config server. Okay. All right. So let's deploy our apps. So I'm going to say kubectl apply apps. And just I'll point out real quickly here, again, we have all the services and everything here. I do have a config map and secret for the Toys Bestseller application that I've specifically created here to demonstrate the fact that we can fetch data from config maps as well as the GitHub repo. And this is how we're going to enable Chaos Monkey. Right now, you can see it's disabled by default, and we're going to show enabling that. The secret is not used for anything. It's just demonstration of you can pull data from the secrets, as we'll see in a second. There's also an application config map, which gets applied to all applications that are pulling data from the config server, just to demonstrate that as well. But again, it's not particularly important or useful. Oops. Should probably not mess with it. All right, so those should be all up and running. Great. I'll start out with the discovery server again. I'm just going to quickly show you that we have all the services running. I'm going to scale up. Well, actually, I'll show you the services first. So now if I refresh this discovery server here, we have the gateway, we have the hot deals service, we have the Toys Bestseller service, and all the other ones, the fashion service, right? All here now. Great, so that seems to work. I'm going to scale up one of the instances just to show that we can have multiple instances running. So we're going to wait for that to finish in a second. I mentioned we also have the config map here for the Toys Bestseller. You see that here. That's been created. Look at the config server. here. So we're going to change the config server request to be the toys bestseller. Bestseller. All right. So if we look at the property sources that get returned here, we see we have the application.yaml config map, which again is just gets applied to every application that would make a request to the config server. We have the config map for the toys bestseller here, right, with our chaos monkey enabled set defaults. We also have the secret that's not used for anything here, but it's just a demonstration of that. And then again, we still have our configuration coming from the GitHub repo as well. Now, just jumping back to the Discovery server, we look and make sure that the hot deals application scaled correctly. It did. So if I go back to my Discovery server here, refresh that, I'm going to see we should have 3 instances of the hot deal service. So 1, 2, 3. I can also, for example, narrow down my request here to just show me details about the hot deal service. And that then just shows 3 instances. If I want to see a specific instance, there's also an endpoint for that, right? And this is all just really adopted from the API from Eureka. It behaves the same idea. So if I change this and oops, I also the instance ID, we'll just see the specific data for that. So I think it's just sure. No, I can't remember the API endpoint at this point. I might have messed up the ID too. Anyways, you could drill down to a specific instance. I think it's instance/instance. Try this one more time. There we go. So this is the specific instance. I just remember the endpoint. So yep, that's the Discovery server. All right. So as I mentioned before, we have our toys bestseller. It has Chaos Monkey set in it. So if we look at this, so 8081/actuator/env. If we look at, scroll down here, there's lots of stuff going on, but we should be able to see, oh my goodness, so many properties. We see the config server config map property source here for the application. We see the toys bestseller config map property source. Again, this is fetching all information from the config server running on Kubernetes, backed by the GitHub repo, as well as the config maps and secrets. So we see all that stuff surfacing here inside the actuator endpoint, the environment actuator endpoint. If we look at the Chaos Monkey, here it's at defaults. I'm going to go ahead and look at the deployment for the config watcher. I'm going to look at look at the pod. Config watcher. Here, I'm going to go ahead and change this to be true. Click save. So we have about a minute left, so hopefully I can get this in. This should send a refresh event to the toys bestseller service. Eventually, maybe. Come on. Come on. There we go. There, sent the refresh event. If I go back here and we see it's enabled, now true. So if I go to my gateway, services gateway, real quickly here. 70/start page. Here we get our gateway data. We see the remote service, and then the fallback. So that's it. That's about all the time I have. I hope everyone joins me in the Slack room and the Zoom session for more questions. Here are links to demo apps. I pasted all the links in the Slack room as well. So thank you.
All right, thanks, Ryan. That was great. Loved hearing about all the Spring Cloud and Kubernetes synergy going on. Next up, we're going to have a small break, but after we come back from the break, we're going to have Stephen Van Beelen talking to us about event sourcing with RSocket. So see you in a few minutes.